All right, we are going to continue our coverage of Alberta's Math 10C with exponent rules. So we're going to look at our curricular outcome and then review some exponent rules. Our outcome, we want to demonstrate an understanding of powers with integral and rational exponents. So exponents are familiar, but exponents that are negative, zero, or fractions may be new. Let's review the exponent rules from previous courses. First, multiplying products with a common base. We're going to just end up adding those exponents. Why? Well, remember, an exponent is just how many copies of that number we're multiplying together. So if you have m copies of a multiplied by n copies of a, well, then the whole thing is just m plus n copies of a. So that's a to the m plus n. Now, a quotient rule. Quotients with a common base, meaning this is a to the m divided by a to the n, not b to the n or c to the n. Well, again, that's m copies of a in the numerator, n copies in the denominator. We keep canceling until the lowest number is gone. We're going to be left with m minus n copies. So if there's more in the first number, these copies will be in the numerator. If n is greater than m, these copies will be in the denominator. Okay, so this becomes a exponent m minus n. If you've got a to the fifth over a cubed, 3 a's cancel in both places, you're left with 2. Now the rules for exponents applied to exponents. We're going to end up just multiplying the exponents together. That's because we have n copies of a exponent m. So that's a to the exponent, m plus m plus m plus m. We've got n copies being added. So that is a exponent m times n. Now, products of different bases that have the same exponent. So this here is ab exponent m. So it's like 6 to the 5 could be treated as 2 times 3 to the 5. Well, we could also treat this as ab multiplied by itself m times. That's what it is. That's what the exponent means. We take that ab and copy it over and over and over. We can rearrange those. That's allowed. So if we move all the a's to the left and all the b's to the right, we've got m copies of each. So that's a exponent m times b exponent m. So if we have common exponents, we can bring them in and out of that expression. Now, quotient with different bases. Almost identical logic. It's that fraction multiplied by itself n times. So we have a to the n over b to the n. That exponent just applies over the brackets, almost like the distributive property. Let's look at more examples. So let's calculate 2 exponent 2049 divided by 2 exponent 2046. Not all calculators can do this. You put this in, a lot will choke. Notice also, there weren't a lot of tech expectations for the outcomes here. We should be able to do it by hand. We do this one by applying the power of a quotient rule and subtract the 2. 2049 minus 2046 is 3. 2 cubed is 4 times 2, which is 8. Let's simplify this one. So we're going to take it step by step. We can only simplify if the bases are common. So we could do 75 over 50 and simplify it. Then just the x terms, just the y terms, and just the z terms. So writing this out, 75 over 50 has a common factor of 25. That turns it into 3 over 2. Now for the rest, we are looking to say 7 minus 2, 5 minus 4, 8 minus 3 as our exponents, because it's numerator minus denominator. That simplifies to 3 halves x to the 5th, y, z to the 5th. All right, example 3. Here we take our numerator and make 3 copies of it. Multiply them together. So 6 cubed is 216. X squared cubed is 6. That's power of a power. We're multiplying. 5 times 3 is 15. 4 times 3 is 12. The exponent only applied to the numerator. So 216 over 4 is 54. Our x's simplify to x cubed. Y becomes y to the 13. Z becomes z to the 5. All right, exercises. Let's try some yourself. So let's calculate this one. 3 to the 52 times 3 to the 16 over 3 to the 66. Pause now. Take the time you need. In our fraction, 3 to the 16 cancels. We're left with 3 to the 50 on the denominator. Or we can just add and subtract the exponents. We're left with 3 squared. Because 3 to the 52 minus 3 to the 50 is 3 squared. Multiple approaches will get us here. This simplifies to 9. How about this one? All right, focusing again on the even exponents. 512 over 64 is 8. The q's simplify to q to the 6, r's to just r, s's to s squared. Now here, remember our order of operations: bedmass, brackets, exponents, division, multiplication, addition, subtraction. We deal with the exponents outside first, then simplify. In which case we are left with 32,400, x to the 22, y to the 8, and z to the 12. That x to the 22 is x to the 28 minus 6. 4 times 7 is 28. 3 times 2 is 12. 3 times 2 is 6. 28 minus 6 gives us our 22. In summary, the product of two bases, or two numbers that have a common base and different exponents, we add the exponents. We subtract them if we're dividing. If we have an exponent with an exponent, we multiply them. And if they're side by side, they can be treated as one, but they have to be part of the bracket. So if you have a 3 outside, then a bracket for the radical and the square roots, the 3 won't automatically come inside like that. So this one works with common bases, as does our quotient. Quotient raised to an exponent is the same as the numerator with that exponent divided by denominator with that exponent. All right. If you have questions, feedback, comments, anything like that, please leave them in the comments. I will try to respond in a timely fashion. Maybe someone else will answer first. Who knows? That's the way the YouTube communities work.